to know about the overall applications of AI and ML for mechanical engineers as well as in general, and also basics about how AI ML will be applied and what are the applications, advantages of AI ML in mechanical engineering, especially the problem solving and also the overview was covered in yesterday's session. And today first session will be covered by Dr. Ilaiah, that will be on regression analysis and clustering. There is also a basic part before going to application and applying AML techniques in our case studies, in our research applications. So that's why actually regression and basics were planned. Some basics were planned with computer science faculty, and further we planned with mechanical engineering experts. So we'll start with speakers on. We'll start the session. Vikram sir?
Sir.
Yeah, you are available, sir. Yeah.
Hello.
Yeah, my voice is audible, sir.
Audible, sir.
Okay. Dr. Ilaiah has joined. I will start. Okay, no
Yo.
The screen recording is on, no?
Hello. Sir, good evening, sir.
Good evening, sir.
So welcome to this FDP program, sir. Thank you for accepting this invitation and delivering session to our faculty.
Good evening, Dr. Ilaiah.
Good evening, Venkatesh, sir.
So, are you ready, sir? We'll start.
Yeah.
The session.
I'm ready, sir. You can proceed.
Yeah. So, once again, welcome you all, dear participants, for the second day of our program, FDP program. So, today's expert is Dr. Ilaiah Kavati, Assistant Professor from NIT Warangal in Computer Science Engineering Department. He has done his PhD from University of Hyderabad in 2016. He has completed, and he completed his BTech and Master degree from JNTU Hyderabad in the year 2004 and 2010 respectively. He is having overall teaching experience of 12 years, and his major research areas are image processing, AI and ML, IoT, security, etc. So he has published more than 40 publications in his research area to his credit, and he is guiding more than 3 research scholars. He has completed more than 10 MTech dissertations to his credit, and presently he is also taking care of Institute NIT Warangal Institute website and as well as email ID throughout the institute. Yeah. With this brief introduction, I would like to call Dr. Ilaiah to take over the session.
Yeah, thank you, Dr. Venkatesh, for the nice introduction. And good evening, dear participants. And today's session is basically on regression and clustering methodologies. Actually, regression is a supervised learning, whereas clustering is unsupervised learning. I think these topics may be covered in the previous sessions. Okay, anyway, I'll spend 2 or 3 minutes on what is supervised and what is unsupervised. Then we'll enter into our topic.
Sorry, your PPT is
Yeah, just I'll share, sir. Yeah. Yeah, okay. So before moving on to regression or clustering concepts, so what exactly actually regression? So, regression is a supervised learning technique. But before to that, what exactly supervised learning? Okay. So, in supervised learning, actually, basically, machine learning is of divided into two types, right? Supervised and unsupervised. We will also have reinforcement. Right? I will actually concentrating here on supervised and unsupervised. So, basically, machine learning stands for making the machine to learn for the things and act like humans. Okay, suppose how will react, how a human will react to the situations. Okay, like that, the machine also has to do the same. Suppose if as a human, if you observe something, suppose this is a bottle, so the machine also has to say this is a bottle, right? So on its own, it has to predict what exactly that object or thing or whatever it is, right? So coming to supervised, basically we'll make the machine to learn based on, actually we'll provide each and everything to the machine so that in future it will predict the things accurately. Suppose, for example, I'll tell you a few simple examples. Like, suppose in a class, as a teacher, let's say some programming class or some mathematics class or whatever it is. So as a teacher, in the class, we will explain suitable examples to the students so that he will be able to learn the concepts, right? So at the end, what exactly we'll do, we'll give some assignment or we'll conduct some tests, right? So we will teach suitable examples, means we are giving proper training to the student, and at the end we are evaluating the student understanding. So like that, suppose if the student is able to solve that problem, so we can say that he learned properly. Suppose if he did some mistakes, so he need more training, more examples to explain. Okay, so like that in machine learning also, in supervised learning, we will provide each and everything to the machine. Each and everything means by suppose that is a situation. What exactly that situation will means that labels we will provide to the machine. Suppose. Uh, um, Suppose let's say he's a boy, she's a girl, this is a ball, this is a pen. Means we are giving that, we are showing or we are providing that object and what exactly that object is. So that it will learn the things. So in the near future, like in the future, it will predict the things accurately. Like how a student is able to solve that problem by understanding the teacher's examples, right? So likewise, the machine also will learn the things and make the predictions. Okay. Suppose if the machine is able to predict perfectly, you can say that it was trained properly. If the machine is unable to do, means there is a misclassification, misprediction, then it needs more training. So actually that is called supervised learning. Right? So we will provide as a supervisor, in PhD or MTech or BTech students, we will supervise them. Means in their projects, in their assignments, right? So how we are supervising, we will provide each and everything, required material, required examples, right? So like that, for the machine also, we will provide each and everything so that it has to do the predictions. So that is supervised. Now coming to unsupervised learning. Coming to unsupervised learning, just we will, let's say, small example I'll explain again here. So let us assume there is a some football match or some cricket match. So as a layman, actually I don't know which teams are playing there, but my job is to segregate them into two teams. So let's say cricket. We don't know that is India, Pakistan, or between two teams. But how, as a layman, I don't know cricket. I don't know Sachin Tendulkar. I don't know Virat Kohli, or I don't know Babar Azam, or right. So just I went to the stadium and I was in the means I'm just seeing that match. And my job, what is my job there? I need to segregate the teams into two. So how? Basically, any answer from the participants? So how I can segregate? As a layman, I don't know anything. Simple, based on my observation. See, generally, Indian will have some blue dress.
Jersey.
Yeah, jersey. Based on jersey, simply we can segregate. One jersey means that the same jersey means that is one team. Other jersey means other team. Based on my observations, I can easily segregate them into two teams. Now, one more example. Same example I will continue. Next job, actually, a set of data is given to me. Like suppose in a team there are 11 players, right? So that data of those players will be given to me. Means the data means how many runs he scored in the last 10 matches and how many wickets he taken in the last 10 matches. Now my job, I have the data ready, right? So player one are okay as our Indian team, Rohit Sharma, like next Virat Kohli, next Cheteshwar Pujara, like that some 11 players data is given. I don't know. Virat Kohli is a batsman, right? I'm a layman. I'm new to the cricket. But now my job is to segregate them into batsmen and bowlers. How we can do it? So I have the statistics. Generally, by observing the data, batsman means he will score more runs. Right? Generally, bowlers will take wickets. They will not score runs. Right? So now by observing the data, the scores is last 10 innings scores. Based on that data, I can say that if he scores more, he is the batsman. Means average above 30 or 35 like that. Right? So if you take more wickets, then he's a bowler. Right? So like that, I don't know is Virat Kohli or is Bhuvneshwar Kumar or Bumrah or whoever, right? But based on the data available, and my observations over the data, I am able to segregate into batsmen and bowlers. So here, what exactly we are in unsupervised learning means we are not providing anything, just the data we are providing. So based on by observing the data, right, we need to segregate. But in supervised learning, what we are saying is Virat Kohli, his scores is this much, he is a batsman. In supervised learning, we are feeding like, we are training the machine like, he is Virat Kohli, he is a batsman, right, everything we are saying. But in unsupervised, what exactly we are giving? Simply the data, that observation, based on observation, I need to segregate. Okay, so this is a simple basic examples between supervised and unsupervised learning. Now coming to so anyway, supervised again we have two types: regression and classification. And whereas in unsupervised learning, that is the unsupervised learning, we have clustering concepts. So at the end we will discuss that unsupervised learning, that is clustering concepts. But now in supervised, we have two different types. What is that? Regression and as well as classification. Now, I'll tell you the difference between regression and classification. Generally, suppose, let's say, I'll ask you one question. What may be your salary in the next academic year? Means, what may be my salary in the next academic year? That is one question. The second question, I'll ask you, in the next academic year, I may get promotion or not. So what may be my salary is one question. Second question is whether I will get promotion or not. Means let us assume I am assistant professor now. In the next academic year, whether I may become associate or not. That is promotion or not. Next, just remember that. First question is what may be my salary. Second question is whether I will get promotion or not. And coming to one more example, so student case, let us assume what may be his marks in the programming subject, that is C programming subject. What may be his marks? And second question I'm asking for the second example, whether he will pass or fail. Okay, got it? These two questions. First question in the case of faculty, what is that? What may be my salary? Whether I'll get promotion or not. And in the student case, what may be his marks in the programming subject? Second question is whether I'll pass or fail. Okay, so here the first question for the example 1 and 2, there comes under regression problem. Means what may be my salary, and the second question is how many marks I will get. What may be my salary? I am predicting the salary. What is salary means? A quantity, a value I am predicting. Correct? The second example, student case, what may be his marks? A value, a quantity I am predicting. Right? What may be my salary? What may be my marks? Salary and marks are values. Right? They are regression. Predicting a quantity is called, predicting a value, a continuous value is called, that is a regression problem. Now coming to the second, whether I will get promotion or not. Whether student will fail or pass. Yes or no, promotion or not. Whether I will get promotion, yes or no. I will pass or fail.
The slide is not moving, sir, I think.
Yeah. I'm just explaining the introduction only, sir.
Okay, sir. Sorry, sir. Thank you.
Yeah, just explaining the basics. Right? So in the first case, I'm predicting a value, marks or the salary. In the second case, I'm predicting whether I'll get promotion or not. Yes or no. Student will fail or pass. Yes or no. Okay. So that is a categorical value. Yes or no. Binary value. Right? Yes or no. 1 or 0. True or false. Right? That is called actually classification. Okay, that is binary classification, but still we have simple other means multiple classification will also be there, not only binary classification. Suppose let's say in human's case, gender, whether is a male, female or third gender. There are three cases, right? Male, female or third gender. Right? Or suppose animals case, elephant or tiger or lion or monkey or something. So multiple classifications are there, right? So we need to predict a categorical value, right? So that is classification. Now coming to, so now we are in this session we are going to cover regression, not classification. So regression, a form of statistical modeling that attempts to evaluate the relationship between one variable and one or more other variables. It is a form of global analysis as it only produces a single equation for the relationship, a model for predicting one variable from another. Okay, I'll say. So now coming to the same examples, salary and marks. Here, what we are predicting the salary. That is the outcome, right? But what are the dependent parameters on which the salary depends? You know, generally, our salary will depends on our experience, right? Experience means teaching as well as publications as well as our feedback, right? Our they are called generally academic performance index, API, right? So my salary in the next academic year will depends on my performance in different categories, like my experience teaching, research, as well as my feedback, different things. Okay, so here in this case, salary is the outcome, that is the dependent parameter. That salary will depend on input parameters like experience, feedback, and etc. Okay, so in regression, so that's why regression is a form of statistical modeling that attempts to evaluate the relationship between one variable, that is the dependent variable, outcome. The dependent variable is called outcome, and one or more other variables, they are called independent variables. So one or more in our salary case, there are more parameters, right? So experience, feedback, etc., etc. Right? So predicting means dependent variable, predicting the dependent from using the independent variables is called the regression. So it is a form of global analysis as it only produces a single equation for the relationship. Okay. Now, so simple, there are few examples again I'm going to explain. See here, so in the linear regression case, suppose here estimating price of a house, generally, that depends on lot of parameters. The price of a house, suppose in Hyderabad or in Bangalore. So the price of a house will depends on the area. Area means location, the size of the means the area of the land, right? Number of floors, right? So the house price is the dependent, that is on y-axis always. Will depends on one or more independent parameters, right? Suppose generally this is, let us assume that is in Hyderabad, what may be the price. So generally in particular area, Amirpet, generally the rate, that means for square yard, the rate is common, but as the size increases, as the size of a house increases, generally the price also increases. So you can observe here, as size increases means as the on the x-axis that value is increasing, right? The y-axis also, the y value is also increasing. So as size is increasing, price is increasing. So there is a linear relationship between this independent and dependent parameter, right? So that's why this particular problem we can model it using regression. Okay. Now coming to actually regression is also many types: linear regression, non-linear regression, multiple regression, etc. Will be there. So in linear regression, generally we'll consider the important attribute, important independent parameter. Okay. Suppose if you consider multiple parameters like so in this case, we only consider size of a house, right? So suppose if you want to consider, the area means the location, right? Etc. etc. Then in that case, we need to use multiple regression. Okay. So here again, this is linear because y is linear with x. Okay, suppose in some cases y may not be linear, that may be non-linear. So in that case, we'll use non-linear regression model. Anyway, we are discussing the basics only. Suppose you can see as the size of the house increases, the price also increases. So you can draw a line like this. Suppose see here. So this line almost passes through the here. If you model this, it will passes through these dots, right? So what is this dot here? The size is here, and the price also. Let it increases as per the size. Now coming to linear regression, you can see here as y increases linearly with x. So this is a linear model, right? Y is linearly dependent on x. So you can simply model this one using the simple this equation linear model. For linear model, we have the equation y equal to mx plus c, right? So where m is the slope and c is the y-intercept, and y is the dependent variable, that is cost of the house, and in this case x is the independent variable, that is size of the house. Just take this one. So x is the size of the house, so y is the price of the house. So here x is my experience, y is my salary, right? So simply we can model this linear regression model using this equation. Mathematical equation is y equal to mx plus c. So another example you can see here. Generally, the sales of the ice cream or these cool drinks will depends on the temperature. So as temperature increases, the sales also increases. Means as x-axis. So y sales is y and x is temperature. So y will linearly depends on temperature, right? So y is linearly depends on x. right? So generally in summer, the temperature will be very high, so the sales also will be very high, correct? Now, as the temperature is low, the sales will be low. So we can draw a linear line, so which we can plot using y equal to mx plus c. So that is this line y equal to mx plus c. This is called actually the regression line. This the regression line, actually the relationship between x and y is not always positive. Sometimes it will also be negative. So you can see one example here. So here I'm going to explain a simple example. So distance traveled versus speed. Suppose using car or bike or your walking speed. As my speed increases, I can travel more distance in a constant time. Let us assume in 1 hour. Let us assume during our morning walk, generally we'll or the schedule maybe 7 to 8 or 6 to 7. Let us assume 6 to 7. 1 hour is my walking time, right? So if my speed is very high, means if I means if I walk with more speed, I can travel more distance in 1 hour, correct? So you can see here, if my speed is 10 meters per second, I can travel 36 kilometers. Let us win 1 hour or 2 hours. Here time is constant, 1 hour time, right? If my speed is 20 meters per second, I can travel again more distance. If I still increase my speed 30 meters per second, what may be my distance? The distance traveled also increases. So as speed increases, distance increases. So this we can have, this simply we can have here the line is having positive slope of the line. As speed increases, distance traveled also increases. So x increases, y increases, right? So here in this case, this is called positive slope of the line, positive relationship between x and y. But now the second case, let us assume distance is constant. So my aim is during my morning walk, I need to walk for 3 kilometers. So power shut down. There is a power problem. Okay, I think my Wi-Fi will work. Am I audible?
Yes, sir,
Yes,
audible.
sir. Yes.
Yes,
Yeah,
sir,
yeah,
you are
yeah.
audible.
Just yeah, my some power cut down here. Right, no issue. So now, what is my aim here? I need to travel 3 kilometers. Correct? Distance is constant here. My morning walk is for 3 kilometers every day. Right? So if my speed, as speed is increasing, suppose speed is 10 meters per second, let us assume it will take 100 seconds to me to travel that 3 kilometers. Let us assume not this is the correct case, or 100 minutes. It means 100 minutes means 1 hour 60, sorry, 1 hour 40 minutes. Okay. But if I still further, if I increase my speed, walking speed, so how much time it will take to travel 3 kilometers? It will take less time, correct? If I increase speed further, the time to travel further decreases. So in this case, you can observe here, as speed increases, time is decreasing. So there is a negative relationship. In the previous case, as speed increases, distance traveled increases. Correct? So here, but what is happening? As speed increases, time is decreasing to travel that 3 kilometer distance, right? So you can see here, there is a negative relationship. So as speed increases, the time will decrease. Like the y-axis, the y value will decrease. As x value is increasing, the y value is decreasing, right? So this is, you can see here, there is a negative slope of the regression line, right? As the speed increases, the variable have a negative relationship. Now, we'll take a small example on how to model it. How to model it. Okay. Right. Let us assume here this x is the independent, independent variable, that is my experience, and y is my salary. So if you want, just note it down. X is my years of experience, y is my salary. Right. So I'll explain you one thing. So here, if my experience is 1 year, let us assume I'm getting 30K. Okay, so this means my experience is 1 year, I'm getting 30K. My experience is 2 year. Let us assume one of the employee of our organization is having 2 years of experience, still is getting 20K. And one person with 3 years of experience, he's also getting 20K. 4 years 40K, 5 years 30K. Let us assume our institution is having 5 employees with different experiences, and these are their salaries. Now, how to, so here my aim is to, let us assume this is our data. Now, if a new person wants to join into your organization, a new person, a new joinee is there. So, how to fix his salary? So, already there are 5 employees in your organization. Suppose your management wants to take one more person. Let us assume he is having 3 years of experience. So, how to fix his salary? How to fix his salary, right? So, based on the data available, okay, as a human being, we can say here 3 years means approximate it is around 20K. But how the machine will do that? Okay, so that we'll see now. So just plot these values over the two-dimensional place. So on x-axis, now you have what is this? Years of experience, and y-axis the salary, right? So you can see here these plotted points. So this first dot, first bubble, sorry, you can say it as first point is with 1 year of experience, that is 30K. 2 years of experience, that is 20K. 3 years of experience, that is 20. 4 years 40K. 5 years 30K, right? So the first step to model this one is to find out, means anyway, first we need to have a regression line, right? That line we need to draw, right? To get that line, how we'll get that line? That line will follows the equation y equal to mx plus c. So now we have y data, we have x data. We need to calculate the slope, that is m, and the c, y-intercept. So in y equal to mx plus c, we have x and y. So we need to find out that m and c. So to draw, then only we can draw this regression line, right? So to have that line, first we need to find out the mean of these x values and the mean of y values. So through that particular mean point, mean x and mean y point, the regression line will passes. So this is this red point is the mean of this x and y. So mean of x is 3, mean of y is 2.8. So simply you can see here on x-axis, this red point, on x-axis the value of this red point is 3, and its coordinate value of on the y-axis is 2.8, right? So 3 comma 2.8. Now the regression line, whatever we are going to calculate, that will passes through this particular line, right? Now let's find the regression equation to find the best fit line. So to find this equation for our data, we need to find out our slope, that is m as well as c, right? So this is the equation to find out the slope, that is sum of x minus x mean into y minus y mean by sum of x minus x mean whole square. So here xi and yi stands for mean of x, yi stands for mean of y. Okay, so to suppose if you see here, the x minus xi is the third column, y minus yi is the fourth column. So x minus xi. So what is the xi mean? Xi, mean of xi is 3, right? So x minus xi, which is 1 minus 3 is 0.2, right? And 2 minus 3, that is minus 1. So like this, you need to calculate this x minus xi, y minus yi, that is under the denominator, and this is the numerator, right? Now sum of this is the fifth column is the denominator value, right? That is the total value is 10, and the last column is the numerator value, that is 2. So numerator by denominator, that is equal to slope. So 2 by 10, that is equal to 0.2. So 2 by 10, that is equal to 0.2. So now we have the slope 0.2, right? Now we have y mean, we have x mean, we have slope. So y mean is 2.8, slope is 0.2, x value is mean x is 3, right? So c equal to y minus mx, y minus mx. So 2.8 equal to 0.6 plus c. So c equal to 2.8 minus 0.6, that is 2.2. Now we have c value and m value, right? Now c value and m value. So what is the c value here? 2.2. That is the y-intercept. So the regression line will start on the y-axis at 2.2. So c equal to 2.2 means what? The regression line will starts on the y-axis at 2.2. So you can see here at 2.2 the regression line started, right? And it is passes through the mean point, the red point. This is the mean point, right? 3, 2.8. Okay, so for this data, this is the calculated regression line. Okay, now let us assume a new joinee is there with 4 years of experience. So how to fix his salary? How to fix his salary? Just a minute, actually my digital pen is not working today. So anyway, this is the regression line we computed, right? Now we'll see how accurate this particular regression line. Okay. Now using these c value and m value, right? Now we'll predict the y values, means the salary for different years of experience. So now predict the values of y. Y means salary for different x values. X means experience. So as now we have that regression line. So for 1 year of experience, what is the predicted y value? So how our management will predict the salary, right? Now, so m is 0.2, right? Slope, and suppose let us assume x equal to 1 year. That is years of experience is 1 year. Now the predicted y value equal to, this is m into x. 0.2 into 1 year plus 2.2 is the y intercept, c value, right? So this is 2.4. And for 2 years of experience, it is predicting as 2.6, means 24,000 here, 26,000. And the third row for 3 years of experience, x equal to 3, it is predicting it as 28k. So for 4 years, it is predicting as 30k. For 5 years, it is predicting as 32k. So these are the predicted. Actually, this is the model we developed, right? Based on the available data, right? We are giving this data as input to the model, right? Whatever the 5 employees data, right? So now we trained that model using that 5 employees, right? Now,
Hello, sir.
yeah, tell me, sir.
Sir, can you please explain how the constancy has been calculated?
Yeah, here this is c value, no, sir. So we have y mean. Y mean is 2.8, correct?
Okay.
And mean is mean value is 0.2, right? Sorry, slope
Okay.
m value is 0.2. The slope value we calculated in the previous year.
Okay.
M is 0.2, and the mean y value and mean x value is 3, 2.8. Just substitute the y, that is mean y is 2.8, and slope value is 0.2, and mean x value is 3. Right now, only remaining parameter is c here. So
Okay.
2.8 equal to 0.6, 0.2 into 3, that is 0.6, right? So c equal to 2.8 minus 0.6, that is 2.2. Right, sir? So this is c value, predicted c value. Now the regression line will start from the y-intercept, right? So y-intercept means on y-axis, the line will start at 2.2. On y-axis, see here, on y-axis, the red line started at 2.2. So that is called y-intercept, correct? So it will passes through the mean x and mean y. So you can draw a straight line, right? So this is the regression line. Now this is the model we developed. The means in linear regression develop means computing the regression line is the task, actually important task. Then if we have regression line, we can easily predict. Regression line we have means what? We have the slope and we have the y-intercept, correct? Because it will the slope of this one is 0.2, right? And it started at 2.2, right? So it will passes through this and this regression, what is that? Mean points. Now we have this M and C, we have X also, correct? So we have M and C, we have X values. That is 1 year, 2 years, 3 years, and 4 years. And these are the different Y predicted values, predicted salary values. Let us use. Now, if an employee comes with 1 year of experience, simply use this model, means substitute, means place that experience in that equation, right? So X is 1, so 0.2 into 1 plus 2.2, that is 24,000. It's 2.4, let us, right? So like that, you can compute the, predict the salary of the new joinees with some years of experience. Now you can see the X is the years of experience, Y is the salary of the existing employees, correct? The second column. Already existing, we have 5 employees and this is their salary, right? Now, if a new joinee comes with 1 year, our model is predicting it as 2.4, correct? Because in the previous step, we calculated. With 1 year of experience, it is 2.4 and the second row is 2.6, means for 2 years, and for 3 years it is 2.8, and for 4 years it is 3, and 5 years it is 3.2, right? So now you can see the actual salary, a person, actually an existing employee with 1 year of experience, he is getting 30K. But for a new joinee, our model is predicting it as 24K. So there is a difference, correct? Actually, this is called the difference is called the error in the prediction. The error in the prediction. So you can see here, the red dots are the predicted values because the regression line we draw already, right? So now if an employee comes, simply using this regression line, we can fix his salary, right? On x-axis, what is his salary? And on y-axis, we need to draw a line. So that easily we can predict. But the blue dots are the original values, existing employees data, right? So there is a difference between original salary and predicted salary. So that is called actually the error, right? So always we need to have a regression line such that, because actually this is very less data, so that's why this much error is there. But if we have means more data for training, so that error will be a little bit less. Okay. So always we need to have a regression line such that the total error in the system, the total error in the model, total error means the sum of all these errors should be minimum. Okay, so the regression line we need to compute such that the total error should be minimum. So here a lot of methods are there to compute the error, that is sum of squared error, absolute error, right? Different error. So our goal is to reduce this error, right? So minimizing the distance, right? There are a lot of ways to minimize the distance between the line and the data points, like sum of squared error, sum of absolute error, root mean square error, etc. So just we need to have, we keep moving this line through the data points to make sure the best fit line has at least, has the least square distance between the data points and the regression line. Okay, so this regression line with means we can say that this is an efficient or means perfect regression line if and only if the total error is minimum. Okay, always error will be there, right? We cannot have 100% accurate model, but that error should be minimum. Okay, so there is a case study here. So if otherwise I'll share with your coordinator so that you can practice it. So I have some data, actually that data I taken from Kaggle. So a lot of resources you can get in Kaggle for beginners. So predicting employee salary based on years of experience. So whatever the case study we taken as of now, so how we can model, how we can build the regression model, and how we can train it, and how we can predict. Okay, all these things that is there. I'll share that code. So if you have Google Colab, means anybody can test it using Google Colab, right? So here a new joinee, same example I taken. How much do we pay for her? So HR team trying to figure out how much to pay to a new joinee. So as years of experience, salary here, right? So predict the salary. Right. Now coming to, this is linear regression. Now coming to logistic regression. This is another regression model, right? Right. Okay. I'll take one example. I'll quickly finish this because we have left with 40 minutes. Anyway, I'll finish this one in 10 minutes. Right. So logistic regression. So whatever the linear regression model as of now we discussed is used for regression problems. Just note it down. This is very, very important. Linear regression, whatever we discussed as of now, will be used to address regression problems like predicting salary, predicting marks, predicting sales of a product based on season or etc. Right? So predicting a quantity, a value, right? So that is a regression problem, correct? So linear regression is to address that this one, right? Predicting a quantity. But here this logistic regression, actually this will be used for classification problem. That means whether I will get promotion or not, whether I will pass or fail in that particular subject, right? So in this situation, yes or no situation, that is classification, we'll use logistic regression. But why the name, similar name, regression and regression here? Because the mathematics behind this logistic regression will derive it from the linear regression equation, that is y equal to mx plus c. Okay, so logistic regression is to solve the classification problem, but why the name is similar to regression? Because the logistic regression mathematical function will derive it from the linear regression function, that is y equal to mx plus c. Okay. So in this case, suppose if you take this example, we know that here as the students spent more hours, on x-axis you can see here, this is a different example. As the number of hours studied increases, means if a student spend more hours on reading or practicing, he'll get more marks. So means as x-axis, x value is increasing, y value is also increases. Correct? So this is actually whatever we discussed, linear regression, right? This is the linear relationship. Y increases, x increases, and y increases. Right? Size of the house increases, price of the house increases. Right? So this is similar, but the linear regression, with linear regression, we are predicting the marks, but we cannot predict whether he will pass or not, whether I'll get promotion or not. Right? So in this situation, we'll use logistic regression function. So for example, a linear regression graph can tell us that with increase in number of hours studied, the marks of a student will increase, but it will not tell us whether the student will pass or not. Okay, so in this situation, we'll use logistic regression. So you can see here we have, the logistic regression function is actually called the sigmoid function, or this is also called logit function, sigmoid function or logit function. So which will apply over the linear equation, that is y equal to mx plus c. See here. So on the left hand side, you can see the below the figure, there is an equation y equal to mx plus c. So in the sigmoid function, this is a cost function, or we can call it as cost function of the logistic regression mathematical function. So you can see this is a probability, yes or no, right? True or false, pass or fail, right? So the P stands for the probability, right? So P equal to 1 means he will pass, P equal to 0 means he will fail. P equal to 1 means I'll get promotion, P equal to 0 means I'll not get the promotion, right? So P is the probability of occurrence equal to 1 by 1 plus e to the power of minus y. So where y is the mx plus c, where y is the mx plus c. So now I'll explain you with some. So here I think we have some whiteboard, right? But do not have the pen. Start a new whiteboard. Need access to people. Access. No, anyone with the link to view. So simply, this is no, this is not working anyway. Okay, no issue. So simply here, as the y value is decreasing, so y value is decreasing means y is approaching 0. Okay, so this e to the power of y becomes infinity. That is 1 by e to the power of minus y means what? 1 by e to the power of y. So as y value is decreasing, right? As y value is decreasing, e to the power of y becomes 0. Okay, so 1 by e to the power of y becomes, that is 1 by 0 becomes infinity. So 1 by 1 plus infinity. So that is 1 by infinity. So 1 by infinity means what? 0. So as y value is decreasing, probability becomes 0. As y value is increasing, that is e to the power of y becomes infinity. But this is 1 by e to the power of y, right? So that is 1 by infinity. 1 by infinity means 0. So 1 by 1 plus 0, that becomes 1. So probability becomes 1, right? So this is called sigmoid function or sigmoid curve. Simply you can convert this linear line into a S curve using this sigmoid function. So probability equal to 1 by 1 plus e to the power of minus y. Somewhere I can draw now. Right. Okay, just a minute. I'll explain in 2 minutes. So P equal to probability equal to 1 by 1 plus 1 by e to the power of y. I'm writing like this. E to the power of minus y. I'm writing like this. E to the power of right. Now, just I'm explaining you as y is increasing, y value is increasing, right? So e to the power of y also increases. So this becomes e to the power of y becomes infinity. As y is increasing, e to the power of y becomes infinity. Now tell me 1 by infinity. 1 by infinity becomes what? 0, right? Small number by a large number. This becomes 0. Now in this case, the probability becomes what? 1. P becomes 1. Because this denominator term, 1 by e to the power of y. See, 1 by, that becomes 1 by infinity. This complete term becomes 0. So 1 by 1 plus 0. So 1 by 1, that is equal to 1. Correct? Probability becomes 1. Now, as y decreases, as y decreases, as y value is decreasing, this e to the power of y also approaches 0. As y increasing, e to the power of y approaches infinity. Right? So as y decreases, e to the power of y becomes 0. So this term becomes what? 1 by 0. So 1 by 0 means what? Something by 0 is always infinity. So in this case, what will happen? As y decreases, the denominator becomes 1 plus infinity. That is infinity. So p equal to 1 by infinity. Right? This term becomes infinity. So 1 by 1 plus infinity, this becomes 0. So probability becomes 0. Right? So as y decreases means the marks decreasing, the probability of pass is 0, means he will fail. Right? So like that, this sigmoid function will convert a linear curve into a sigmoid curve. Sorry, linear line, this is not curve. A linear line into a sigmoid curve. Either pass or fail. Okay. Right. So this is logistic regression. So now based on those values, if the probability P is greater than 0.5, the value is rounded off to 1 and indicating pass, and if the value based on the threshold, some threshold, if the value is below that threshold, it is rounded off to 0. That means he will fail. So this is the another case study I have. So I'll share this one also. Predict if a person will buy an SUV car based on their age and salary. Okay, so I have some data. So that is salary and the age of a person, right? And whether that person purchased the car or not. Okay, I have some employees, 400 employees data. So their age, their salary, and whether already they have car or not. Now, based on their age and salary, I have the data, right? Now I'll train the model. Now, if a person comes with some age and salary, whether he will purchase the car or not, that is the model has to predict. Okay, so this is a linear regression and logistic regression, right? Now we'll continue with any questions, please, before moving on to cluster analysis.
Sir,
Yeah.
sir, actually I am not able to understand the main difference between linear regression and logistic regression. It sounds similar. Logistic regression sounds like that of classification type of rental.
Correct, sir. Logistic regression is for classification. Correct.
Okay, for classification.
Correct. Logistic regression is for classification, right? That's what I said. With linear regression,
Classification of variable.
yeah, classification. Whether classification means what? Classes, pass or fail, two class. Either pass or fail.
Then that
Right?
comes under classification type.
That comes under classification. Whether you'll get promotion or not. That class only, na sir. You are predicting two class, either yes or no. But multiple classification
Okay.
also will be there, right? What I said, suppose if there are group of animals or group of people, okay, group of animals, let us assume, right? So we need to classify them into unique, means some classes, wild animals, domestic animals, right?
Sir, one doubt, sir.
Yeah, yes.
Sir, since we are using the regression, for sigmoid function is getting a regression as input. Because of that only, whether we are that name is comes under logistic regression, sir.
Yeah. That logit function we are using, na sir. This is actually the logit function.
Okay, sir.
This is actually called the logit function. The whatever the probability p equal to 1 by 1 plus e to the power of minus y.
Minus y, yes, sir.
This is called logit function or cost function or sigmoid function, we'll call it.
Okay, sir. Okay, sir. That y is since that y is it is
Yeah, we
following
are
the
you.
regression.
Yeah, y just if you substitute this y equal to mx plus c,
Yes.
right? Simply in the denominator part, you are using this y means the outcome of
Yes, sir.
linear regression.
Okay, sir. Because of that only that their name will be
Yeah,
so.
yes sir, yes sir, yes sir.
Okay, okay, sir. Thank you, sir. Thank you, sir.
Actually, there are other regression models also will be there, but as a beginners, you can start with this, sir. Because polynomial regression will be there, means non-linear regression and multiple linear regression, different kinds will be different kind of regression problems will be there. Again, for classification also, just I explained only logistic regression, but there are still support vector machines, naive Bayes, random forest, decision tree, different classification algorithms also there. I think I have the PPT. If you want,
Sir,
I'll
that
share. Yeah.
sir.
Yes, sir.
So in classification, we used to check with the quality, and in logistic regression, we usually check the value of the variable and quality.
Sorry, sir. Can you repeat, please?
In classification, we usually check the quality of the object, and in logistic, we used to check the quality of the material
Based on?
based on values, variable values.
Okay, okay. Quality, quality, quality. Means you are talking in terms of mechanical, sir. Actually, I'm not getting your question.
If student is passing or failing, that is coming under uh,
Yeah, 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 yeah.
classification.
Correct, correct.
And
Pass or
for
fail will comes under classification.
okay, and logistic means
That is only
that
logistic
example that
actually.
you have shown.
Yeah, that is
Okay,
only
okay,
pass or fail, true or false, yes or no. These are classification. Class, predicting a class, yes or no, two class here. That's why this is called binary. Whatever the example I explained is for binary classification. Means only two classes will be there. Either 0 or 1, either true or false, yes or no, pass or fail, either get promotion or not. Means this type binary classification. But there are
okay, sir.
multiple classifications also will be there. Suppose I have one means other examples you can have here. Suppose you can see here. So there are different types of vegetables, three types, right? One, two, three. Now it will comes under three classes, right? So likewise, here you can see there are multiple animals, right? Giraffe, elephant, and tiger, a mouse, etc. are there. So we need to divide them into multiple classes. In one class there are giraffes, in other class it will be elephant, and other class tigers, mouse, right? So like that. So this is called multiple classification. So in your thing also, sir, whether suppose in materials, you have different types of material, right? So which type of material is this? Suppose let us assume that you have five types of materials, right? Now you train the model, right? Now if you input some material, so the model has to predict it belongs to which type of material, which of the five classes. Okay, so that is called classification.
Thank
Still,
you,
I
sir.
have of examples will be there. Okay, then now coming to, yeah, if no question, then we'll move on to the clustering, that is unsupervised learning. Okay, so with unsupervised, with unsupervised, yeah. So the machine learning model uses unlabeled input data. I said right. So will not tell the machine what exactly this one. Whose data is this? That example I taken, right? Virat Kohli. Virat Kohli is a batsman, right? In supervised learning, we'll give that, but in unsupervised learning, we simply give their scores. Now, based on the data itself, the machine has to observe the data and it has to predict whether to which class he will belongs, right? So try to find hidden structure or pattern in unlabeled data. Suppose you can see here, there are a set of objects. Now the algorithm or the model has to segregate into different classes. Now you can see the algorithm by observing the features of these objects or data, right? It segregates into three classes here. See, the objects with 3 vertices or 4 vertices are in one group, like cone are in one group, and the objects with round shape are in another group, and the remaining are in another group, right? It divided into three classes based on the observation. Let's say I'll give like example, like a simple. Suppose I have the data, a circle, and this one triangle and a square. Now this is the data available with me, and let us assume there are some 5 circles, 3 triangles, and some data is there. Now I'll give this one to the model, so it has to segregate these given objects into classes. By observing it as a layman, simply a simple student means a person of UKG or second class or first class, the student, you can easily segregate, right? There are no edges, it is in one group. If there are 3 edges, that is in another group, and 4 edges, that is in another group, right? So simply by observing I'm not saying this is a circle. This is group 1 because this is not having, this is different from the remaining 2 objects, right? So that's why this is in group 1. Okay, this is object 1. This is again different from the remaining 2, right? Based on my observation, because the first one is having simply no edges, but it is having 3 edges, and the next one is having 4 edges. So this is class 2 or group 2, and this is group 3. So likewise, simply I can classify, right? Right. This is called unsupervised. Now, I'm here not saying to the machine that the first one is a circle, the second one is a triangle, the third one is the square. Right? I'm not saying that. Right? This is called unsupervised. I'm not giving any input. Simply I'm submitting the data. I'm giving the objects. So it has to segregate into different classes based on its observation. Means the features of the given objects. That is called unsupervised learning. Right? So we have in clustering, that is unsupervised learning, again we have clustering and association, but our main focus here is clustering. So clustering is used for analyzing and grouping data which does not include predefined class. Means I'm not saying what exactly that object, right? Whether he is male or female, or is a Virat Kohli or Sachin Tendulkar, right? I'm not saying anything. Right? So in the algorithms for unsupervised classic clustering or K-means, hierarchical clustering, hidden Markov models, etc. are there. And again, in unsupervised learning, we have associations. So this discovers the probability of the co-occurrence of items in a collection. So we have different algorithms, a priori algorithm, FP growth. So I'll simply tell you, for association, a small example. Generally in supermarket, if you go to the supermarket, these items related to kitchen are in one rack. So if there is a soap, let us, there is a paste next to that, generally the brush will be there. Okay, they will be, means if that is there, then automatically in the next rack or next to that, this will the associated object will be there, item will be there. The probability of that is more. Okay, so for that actually we will use this association mining or association rules, right? So anyway, I'm not going to cover that. So simply the clustering I'll cover. So here for classes, suppose we have a pile of books of different genres. See, here my job is to generally library. If you go to the library, in library also, the librarian, the people the librarian, they will arrange the books as per the similarity, right? The computer science books are in one rack, and ECE books in another rack, mechanical books in another rack, civil books in somewhere, right? They will segregate them generally, right? So how they segregated the books which are similar, which belongs to a category will be in the same rack. They will have some similarity, right? The books in the same rack means they will have similar. They are having some similar features. They belongs to some same class. That is CSE. In another rack, there are mechanical books, right? Those books are belongs to mechanical people, right? So the similarity there is that belongs to mechanical, right? But the books from a book in CSE rack is completely different from a book from mechanical rack. So here I want to say one point. Assume a rack means a cluster here. A rack means a cluster. So the books means objects. So the objects in the same cluster are more similar. Means the books in the same rack are more similar. Take CSE rack or mechanical rack. All the books, maybe programming or OS related in CSE, right? In mechanical, they maybe belongs to materials or manufacturing or something, right? So they are close. There is some close relationship between those books, right? So that's why clustering, I can say one word, the grouping the objects into clusters based on their similarity, right? So that is called clustering. So you can see now we divide them into different groups like fiction, educational books, horror books, right? So we have here set of books. So segregate them into different based on the content in that. Nobody is saying this is a fiction book, this is an educational book, this is a horror book. Based on the content, based on the title of that book, the library has to segregate, right? Based on the observation only, right? So, organizing objects into groups based on their similarity is called clustering. So here I am going to explain you K-means clustering. So K-means clustering, you can see here. So K-means perform division of objects into clusters which are similar between them and are dissimilar to the objects belong to the another cluster. As I said, the objects in the same cluster, the books in the same rack are more similar, which are similar between them. And they are dissimilar to the books in the other clusters, the books in the mechanical cluster. The CSE books are similar, right? More similar. But a book from the CSE is more dissimilar to a book from the mechanical, right? So that is this clustering, the overall concept. Yeah, same. For understanding K means in a better way, let's take an example of cricket. Identify bowlers and batsmen, whatever the example we take. So the data contains runs and wickets gained in the last 10 matches. So the bowler will have more wickets and batsman will have higher runs. This is the methodology, right? So this is here we have our data set with X and Y coordinates. Now we want to cluster this data using K-means. So on X-axis we have wickets, on Y-axis we have runs.
Sir?
Yeah.
So can you please explain again K clustering?
Yeah, it will
Just
be
in
there,
one
sir.
line.
Yeah. Just K means just as of now I'm explaining clustering only. K means will comes in a means from this point onwards will means I'm going to explain you K means. So
Okay,
here
sir.
K is 2 means because my aim is to segregate into batsmen and bowlers, 2 clusters. So K stands for how many clusters? The number of clusters. Okay, sir. So here, let's say if k equal to 3, somebody may ask, what happens? K equal to 3 means, in this case, batsmen and bowlers. First cluster will have batsmen, second cluster will have bowlers, or second cluster may have all-rounders, means a player who runs more as well as takes some wickets is comes under all-rounders, right? So like that, as per our requirement, we need to choose K, but that I will explain. Now here on x-axis we have wickets and runs, and y-axis we have runs, right? Now we need to divide them into two clusters using two means, that is k-means algorithm, right? So simply you can see here, cluster 1, you can see simply they scored more runs. The working I will explain in the next slides, how k-means will work, right? And in the second cluster, see, if I group the players who score more wickets, that is on x-axis, right? So this is cluster 2. So these are the batsmen with blue, and these are the bowlers with the yellow circle. Yellow means that yellow color. So k-means clustering is an example of unsupervised learning. It is used when we have unlabeled data, right? Here no labels are there. Here we have no labels. We have runs as well as wickets. That's it. So find clusters in the data based on the feature similarity. So what is the similarity here? What similarity we use there? Runs as well as wickets. So means the players who scored more are batsmen. Who scored more runs are batsmen, right? So the similarity is the means their runs will be very closer, right? So this is the working of k-means. Suppose we have these data points and we want to assign them into clusters. Let us assume the same. Now with k-means, the first step is we need to choose the k value. So here our aim is to anyway batsmen and bowlers. So I'll choose k equal to 2. Okay, choose the k value first. So k equal to 2 in this case. And k equal to 2, and the first step is we need to choose 2 points randomly, any 2 points. See here. We pick k clusters and assign random centroids to the cluster. This red star and green star are the random points. Random, they are called mean points. Mean points of the clusters. So here I am choosing randomly some random centroids. So this red star and green star, right? Now the second step is for the first. Let us assume this is actually this is called this is cluster 1, right? Okay, this is the centroid of one cluster, and this is the centroid or mean of other cluster. Okay. Now the second step is calculate the similarity. Means to this cluster it is these data points. For each data point, whether this one is closer or this centroid is closer, because we randomly choose it, right? Now, so how we can check the mean similarity, closeness? So in this case, we'll use some distances. So each point is having a coordinate position, x comma y, right? So as we can see here, these data points are closer to this one, this cluster, right? And suppose this data point, if you take this data point, this is closer to this one compared to red star, right? So all these 4 data points will be closer to green star, right? Now in the next step, so now as per this, what happened? These red points are in one cluster, and green points are in another cluster. Okay, this is one cluster and this is in another cluster because the coloring is given, right? Now in the next step, we need to find out the mean value of the red points, means cluster 1. Let us assume this is cluster 1. and this is cluster 2, the mean point. Okay, so let us assume we calculate the mean point. Okay, the mean point now becomes this one, means the centroid will now move to the next step. What we'll do, we'll compute the mean of all the data points in rack 1 and the mean of the second rack, right? So the based on that, suppose the mean, suppose here there is the mean is this one. Now this data point, sorry, this centroid, whatever we randomly chosen, will move to this position. Okay. Now let us assume for this, you can easily see the mean value maybe come around here. Correct. So the next step will move this randomly chosen centroid for the second cluster will be moved to here. Okay. So you can observe this one here. So there is a movement of centroids in the second step. Now the third step again we'll repeat this step. Iterate means we'll compute the mean of all these and again calculate the distance of the newly computed what is this point? This called centroid with the data points. So based on that, it will be repeated for until there is no variation or no change in the centroid points. Okay. So repeat previous two steps iteratively till the cluster centroid stop changing their positions and became static. So just see here, the first step is we need to choose the k value randomly, right? And from each data point, calculate the closest centroid and assign the data point to that cluster. Okay, we pick a cluster and assign random centroids to clusters. Then we compute distance from objects to the centroids. Okay, so yeah.
So clustering is used for unsupervised learning and regression is for supervised learning.
Regression is supervised learning. We call it as regression is under supervised learning.
Okay. And clustering under unsupervised learning.
Clustering is unsupervised because we are not giving any labels.
Okay.
Just we are giving data.
Okay.
Right. Now the second step is we form new clusters based on the minimum distance and calculate the centroids again. So this process will be repeated iteratively till the clusters, and means there is no changes in the means. Okay, that is called k-means clustering algorithm is called k-means clustering is converged. Means it becomes static. There is no change. Right. So once the clusters become static, then k-means clustering algorithm is said to be converged. So this is the flow chart for that. So first we need to choose the k value, but the choosing of k is very, very important. So assign random centroids to clusters, compute distance from objects to the centroids, form new clusters based on minimum distance and calculate their centroids. So compute distance from objects to new centroids. This process will be repeated until the centroids become static. So this is an example. Suppose we have this data set of 7 individuals and their score on 2 topics. Let us assume subject and subject 1 and 2 topics, chapter 1 and chapter 2. Let us assume some score. Now, how to form the clusters. So here, let us assume we need to means k value as 2. So the first cluster centroid is this one and the second cluster centroid is this one. Randomly chosen 2 points as means the first point as well as fourth point as the initial centroids. Okay, if you plot these data points, okay, this a comma b 1 comma 1 1.5 comma 2 like this is the plotted values. Now just randomly taken 2 points, this one and this one as the cluster centroids. The next step is what we need to do. We need to find out the distance of each data point to these cluster centroids. So assign this data point to the closest cluster, closest centroid. These two are the centroids. The first, the red colored points are the centroids, randomly chosen centroid. Now the remaining points will be assigned to the closest centroid. See here. Compare for these two objects, for this object as well as this object, you can see This one is closer. This one is closer compared to this one. Correct? So that's why here we formed two clusters. Mean these two objects, this object and this object will belongs to cluster 1, and these three objects will belongs to cluster 2. Right? Now in the next phase, what we need to do? For these formed clusters, we need to find out the mean of these cluster points. Now, the mean of this cluster point now becomes this one, and the mean of the second cluster becomes this one. Right? Now, again, we need to find out for these new centroids, the distance from each object we need to find out again. Right? Now if you observe for this data point, which one is closer? Either second cluster centroid is closer or first centroid closer. As per our observation, we can see that this distance is small compared to this distance. Right? So that's why now this point is it will be moved, means this point will come under now cluster 2. Just you can see in the next case. See, this is closer to this, so there is a change in the cluster points, right? Now again, now these 2 points will becomes this one and this one will becomes in cluster 1, and the remaining points are in cluster 2. Again, we need to find out the centroid of cluster 1 and cluster 2. This process will be repeated, right? Now the cluster centroids will change. Now this is the centroid and this is the centroid for second cluster. This process we need to repeat again. Again, for each object, you need to compute the distance of the cluster centroids. See, there is no change. So that's why we can say that the clusters are K means is converged. You can stop it, right? And how to fix the K is very, very important. So here, to fix the K value, we'll have a method called elbow method. So which is an optimization algorithm. So where we'll get a good clustering. Okay, the results will be very good. Okay, this approach is called elbow method. You can go you can search in the literature for this. Okay. Yeah, there are multiple use cases to predict weather conditions using machine learning to identify the areas which are exposed to rainfall, means clusters. So where there may be heavy rainfall, where there may be moderate, where there may not be any rainfall, right? So based on, if you want to divide into 3 places, means more rainy, less rainy, average rainy, right? So 3 clusters. So to do that, we can use this type of analysis based on weather conditions. Right. Yeah, if you have any questions, again, different algorithms will be there actually. K-midoid also will be there, and there are different clusterings. Like these are actually static clustering algorithms, because static means we are fixing the K initially only. But there are many. Actually, have a lot of data. If you fix K value, just I'll show you one example. Yeah, suppose for this data, how many clusters? Suppose this is the data items. Suppose if K value is 2, this is in one cluster, right? This red one, and this is in another cluster. But 6 clusters, suppose K value is 6. See, you can see here, this is in one cluster, these are in another cluster, these are in another cluster. So 6 clusters are formed. 4 clusters. This is the output. But how many clusters? Which is efficient one? Okay, so that is the problem. Choosing of K is means a problem with the static algorithm. So we have dynamic clustering algorithms. We have, I think, leader algorithm. One algorithm I used in my research. So in leader algorithm, based on the data, means as the the number of data points are increasing, automatically it will generate new clusters as per the requirement. Suppose humans, what I said, there are generally, if we divide into 2 clusters, men and women, suppose if they're third gender, how you will classify it? It should be in either male or female, but that is wrong, right? So choosing of k equal to 2 is not work with humans in that case, right? So that's why some dynamic clustering algorithms also there. You can explore them also as per your requirement. Yeah, if any questions, please ask. I think it is already 5 minutes,
Hello, sir.
7:35. Yeah, yeah, yeah.
So in a cluster, we have to choose the main in such a way that it is at minimum distance from the points.
Correct.
Okay.
The distance, the Euclidean distance or absolute distance, you can choose anything because we have the coordinate positions. Whatever the data available, just plot in the two dimensional. Suppose if that is 2D, because we have runs and wickets, so that is two dimensional. But if you have more parameters, you'll have that many dimensions. So plot them in the n-dimensional space and use the distance similarity measures, like how much similar, how much close. Means how we can say that is close based on the distance, right? Distance means, Euclidean distance. X1 minus x2 whole square plus y1 minus y2 whole square root, right? Suppose if that is absolute distance, simply you can compute the mod of x1 minus x2 plus y1 minus y2. So whatever the distance, you can use cosine similarity also will use, or we can also use some correlations, Pearson correlation or something. Means based on our requirement, based on the data, the similarity means closeness, because clustering means in in the same cluster, the objects are more similar, more closer. They'll have similar features. Whatever I said, CSC books, CSC rack, they are more similar, right? They may be similar to suppose Java programming, C programming, right? .NET programming or Python programming. They are related. In CSC, that type of books will be there, right? But in mechanical, the books are very different from the CSC cluster, right? So that's like that. The similarity, to measure the similarity, some features you need to observe. The features, the features are more similar in the same cluster compared to other clusters. Yeah. Any other questions, sir?
Sir, these algorithms anywhere directly in software available,
Yeah, yeah, yeah. In Python, actually, you have
like NumPy or Panda in that
yeah, yeah, yeah,
any,
yeah. That's what.
anywhere,
That's what. Yeah, they are available,
or
sir. In
all the
Python.
times you have to write the code, or as
No,
per
no,
our
no, no,
problem, we
no.
have.
No. In Python, you have ready-made functions. Just need to import from those libraries, pandas,
Okay,
numpy, pandas
okay,
maybe. Huh?
okay,
That's
sir.
what. Actually, that case study is there with me. Anyway, I'll share.
Okay, sir.
Means you can also develop from the scratch. But
Okay,
in MATLAB, in C, in Java, you need to do like that. But
okay, sir.
with Python nowadays, ready-made libraries are available. Directly, you
Uh,
can use them. So you can
sir.
customize as per your requirement.
Okay, sir. Sir, and for this, any can you refer good textbooks? We can see what are the about this
Uh,
minimum basic data about these algorithms. Better
yeah, yeah, yeah,
understanding purpose, because
yeah,
in
yeah,
1 hour
yeah.
you elaborated like in, but still we can want to learn in another
Yeah.
algorithms, so that
Yes, sir.
we
Yes, sir.
can
Yes,
see the
sir. So books means nowadays books actually I also purchase many books for
anyone good book which will cover all these supervised and unsupervised machine
yes, sir.
learning.
But never will, and means most of the times will I will not go with books, but
Okay.
just refer online videos or
No, no.
online.
Yes,
But
sir. Actually, for starting
for
people, it will help after that.
no, sir, it will confuse you because the books, the redundant
Okay,
content, you need to read more. But if you
okay,
want some concept, go through the some means some material on the
okay,
web. And for
okay.
practicing purpose, sir, you can use Kaggle.
Kaggle.
Kaggles, Kaggle. So where you'll find more data sets as well as code ready-madely available. Just you need
Okay,
to copy that code. You need
okay,
to copy that code into Google Colab and you can run it. Means for
okay, okay,
practicing purpose.
okay, okay.
Yes,
Sir, I'm having one doubt, sir.
yes, sir.
Sir, for that linear regression also, there is sir, some kernel functions are there, no, sir? If the
Yes, sir.
data are very complex, we need to
Yeah, yeah, yes, sir.
it
Yes,
will
sir.
convert
Yes,
it
sir.
to
Yeah,
multi-dimensional.
yeah, yeah, yeah,
That
yeah.
kernel again, it will be reverse back, no, sir? For that output, I'm having little bit doubt on that. For
No, no, no.
example,
Actually, whatever that is actually not that is not this is whatever I explained is simple linear regression, sir. You are asking about multiple linear regression, right?
not multiple, sir. If the data are not linear, if for example, if it is the data are somewhat categorical. If you want to not categorical, it comes under classification, sir. So, what is the use of kernel function, sir? Generally, I'm asking.
Actually, the kernel functions will use actually in support vector machines. It will be there
Okay,
in
sir.
the kernel function.
Okay,
Okay,
sir.
so where here in two-dimensional space, suppose let's say here
Okay,
we
sir.
can easily saying this is class one, this is class two.
Yes, sir. Yes.
Correct, but
Yes, sir.
some situations will be there where we cannot easily say means we cannot easily segregate them into clusters.
Yes, sir. Class one or class
Okay,
two.
so in that case, what we need to do, we need to use some kernel such that it will convert the high dimensional space into two dimensional.
Okay, sir. Okay, sir.
Because as a human, suppose I have one example, I think, but I haven't downloaded that. Yeah, where means as a human we can see only two dimension, right, sir?
Yes, sir.
Correct. So to project the higher dimensional space to two dimensional, so we'll use that kernel function.
Okay,
So
sir.
which we'll use in SVM actually, support vector machines.
Okay, sir. Okay, sir. Thank you, sir.
That is, suppose x, y, z is there. Generally, we'll plot with x and y. But how to compute that z? Okay, so for z, simply the kernel function we'll use is z equal to x square plus y square something. Okay, that will map between means x square y square on now on one axis and z is in another axis.
Okay, sir.
Okay, so like that. Okay, sir. Yeah,
Thank you, sir. Thank you, sir.
yeah, yeah. Yeah. Any other questions, sir?
Yes, sir.
Yeah,
Sir, in unsupervised learning, there is no leveling of data.
yeah, yes, sir, yes, sir,
Hello?
yes, sir, yes, sir, yes, sir. No labeling.
Like, the example, like only number is given.
Yeah, data will be given.
And in supervised learning, there is leveling of data, like marks of student, etc.
Yes, sir, yes, sir. Not marks, like this is marks in, these are the marks of this, so and so. Okay. Or he will in pass class, he will in fail class. Already the classes will be given. The label.
Hello?
No. Hello. Somebody muted me. Now it is fine, I think. Okay. So in classification, along with the data, right? That score means the runs he scored and wickets taken. Along with that, whether he is a bowler or batsman also, that label will be given. Now the machine will train like, okay, a batsman means, for a batsman it can understand that the runs will be very high. For a bowler, because it will check in the number of runs case, they are very low compared to the what is that, wickets, right? So it learns like, if a person scores more wickets, then he is a bowler. So in that way, that machine will be trained. But in the unsupervised case, what happened? Just simply based on the observation, we will not say anything. Means we will not provide whether he is a batsman or bowler, batsman or bowler. Right? Yeah, any other questions, sir, please?
Hello, sir.
Yes, sir.
Sir, generally there are types of unsupervised learning. First one is clustering and second one is association.
Mhm.
What is the main difference between clustering and association?
Yeah. Actually, this association will be used to find out the similar means they are called actually collocation patterns. Collocation patterns. Suppose uh, while we'll search in Google, sorry, let's say Amazon. If you search for a gas stove, let's say Prestige, right? So he will recommend you some things, right? If you suppose you are able to search for Prestige, but in the bottom of the search, you'll get some hits, right? Like Prestige, this is this car, this is this car, this, and at the bottom of that, it will recommend you some other things, like if you purchase Prestige, what is that called, cooker, along with this, means the generally the people mindset. So what will happen along with this, that will, if it means that, if that will be there, so means if he is purchasing this, he also may purchase this. Okay, so that's what in the beginning I said. If you go to the supermarket, next to your brush, means next to the brushes, the brush means that Colgate or whatever, there may be some that paste, soaps, they're all related, right? Generally, if you purchase this one, then you'll purchase that, like that. That association or will use in that association, or that is actually called collocation patterns.
Yeah, thank
But
you,
clustering,
Professor.
yeah, yes, sir. Yes, sir.
Yeah. Thank you, Professor, for delivering the wonderful lecture. And if any other queries, if any other discussions, probably you can mail to the expert. Yeah. Shall we conclude the session, sir?
Yeah,